This is Jody Trana with Chapter 5, Part 2 of Business Finance. For a quick review, get out your financial calculator or use Excel to answer these questions. You should be able to go through them pretty quickly once you have it set up. It's asking the same question over and over again using a different interest rate. So if you were to invest $1,000 today and expect to buy a car in 6 years, how much money will you have if you earn 2%, 5%, 9.5%, or 18%? By looking at this, we can determine that the element that's missing is the future value. That's what we don't know. What we do know is the present value, which is negative 1,000. We also know the periods, which are 6, and the interest rates are given. The payments are 0. So see if you can calculate these. We may have some rounding issues, but your numbers should come out fairly close to the numbers here in the graph. At 2%, around 1,126. At 5%, around 1,340, at 9.5%, around 1,772, and at 18%, you should have 2,986, or somewhere close to that amount, by the 6th year. Oftentimes, when we're talking about finance for a company or for personal reasons, we're just trying to figure out how big and how fast a number can grow. So we often will talk about how long it will take to double an investment. This happens oftentimes in personal finances when you're trying to calculate a certain amount that you want to have at retirement. So let's talk about this. If you know of an investment that you can earn 8% annually, how long will it take to double your investment? Now here all we have is the interest rate. We don't know the initial investment, we don't know the time frame, that's what we're trying to figure out, and we don't know the future value.
So you've got a chunk of change, and you're smart enough, so you put your money into an account that gains compound interest. So how long does it take for your money to double in that account? Well, to find this out, you need two things: your balance and your interest rate. Now, like most things, there's an easy way to find your answer and a hard way. The hard way involves taking the logarithm base 10 of 2 as in 2 times our balance, over the logarithm base 10 of 1 plus our interest rate. Since most of us don't have bionic brains, we can't really do this math in our heads. But our friend Larry is here, and he's gonna give it his best shot. We'll get back to him later. Luckily, there's a simple way to approximate how long it takes for your money to double in a compound interest account. It's called the Rule of 72. How does it work? It's surprisingly simple. All you do is take the number 72 and divide it by your interest rate. That's it. It's that easy. The number you get equals the number of years it's going to take to double your money. So let's try it out. Say you have $5,000 in your account earning 4% interest. Now take that magical number 72, take your interest rate of 4%, pull out your phone, text your second grade cousin and ask him how many times 4 goes into 72. He's a bright kid, so he'll tell you the answer is 18. And you'll tell him that he just helped you learn that it will take 18 years for your initial $5,000 to double into $10,000. Let's check in on Larry. That's very nice, Larry. Luckily, with the Rule of 72, there's no need to ever use the hard way. Using the Rule of 72, we can easily see how small changes in interest rate can make a huge difference in our earning potential. A 29-year-old earning 4% compounding interest can expect his account to double twice by the time he's 65. At 8%, it doubles 4 times. At 12%, it doubles 8 times. So by doubling your interest rate from 4% to 8%, you actually quadruple your money. And by tripling your rate from 4% to 12%, you 16-tuple your money. Is that a word? It is now. Interest rates matter. The Rule of 72 helps us understand just how much they matter. So how many doubling periods does your nest egg have before you retire? Now you know the easy way to find out. For this educational video and others like it, go to alliancegroup.academy.
So how long will it take to double money at 8%? Any amount of money. It will take 9 years. We use the rule of 72 and divide it by the interest rate. 72 divided by 8 is 9 years. During the last class, we concentrated on determining the future value of a present amount. That's called compounding, and you can see the mathematical equation that we used. Today we're going to look at the inverse situation called discounting. We will be determining the present value of a future amount. We'll also talk about the importance of interest rates and how compounding affects the interest rate we pay or receive. The discount rate is the interest rate that you will be using in your formulas to discount the future value amount back to present value. It's usually determined by a company's required rate of return. That's the amount that they would expect to receive on their investments. Let's get started by jumping right into our first problem. It asks, what is the present value of $100,000 to be received at the end of 25 years given a 5% discount rate? What this question is asking is, what is today's value of $100,000 that we plan to receive in 25 years if we can invest at 5%? What's today's value, or what do we have to invest in order to have $100,000 25 years from now? We're going to follow the same steps that we did before, which is to first draw a timeline, to second, identify the elements to determine the solution strategy. We have to figure out, is this a present value problem? Is this a future value problem? Because at some point we're going to have them all mixed together. Step number 3, we need to solve it. We have 4 methods to do that: the present value, future value table, the math equation, the calculator, and Excel. And then step number 4, to analyze and check yourself. The first step is to draw a timeline. So let's go through the elements that you need to have on your timeline. Here you can see that I've abbreviated it and have not included all 25 years, and that's fine. Today is period 0, and you'll notice that the present value will be a negative number, just like it was in our last lesson. Here we have the future value is known, so we have written that in. And we have not written our discount rate on here yet, but writing that on here will help us to remember all the elements. The second step in the process is to identify the elements. If our question was, what is the present value of $100,000 to be received at the end of 25 years, given a 50% discount rate, consider what these elements are and put a question mark beside the element that is unknown. This is a problem to calculate the present value. So the present value is our unknown. The payment amount, even though it isn't given, is known to be 0. Step 3 is to solve it. First of all, we're going to use our present value, future value table. We will be looking at the opposite side of the table this time, as we need to find a present value this time. What is the present value of $100,000? What we need to do is to track the interest rate and where the period meets, where it intersects in our table. And you'll find that that multiplier is 0.2953. I want you to notice that when we are calculating a present value using the tables, that our number, our multiplier, is less than 1. When we were calculating a future value, the multiplier was more than 1. And that makes sense because we're trying to calculate a present value which will be less than our future value. To calculate the present value, we take $100,000 and multiply it times our multiplier, 0.2953, and we will get 29,530. Remember that because of rounding, these present value tables don't work well with MyLab. The second way we are going to solve for the answer today is by using the mathematical equation. To calculate the present value, we take the future value and we multiply it times 1 divided by 1 plus the annual interest rate to the power of the number of years. You can see when we do this calculation that our answer comes out to the same as it did with the multiplier used in the present value future value table, 29,530. To solve using a financial calculator, we enter all the known information into the calculator and we compute the present value by pressing CPT and then PV. You'll notice here that our answer is a negative number. That's how the financial calculator and Excel keep things straight between the today's value, the original investment, and the future value. The present value should be a negative number. And thank you to Excel, they have a built-in equation to calculate the present value. I did want to show you that you can calculate present value in Excel plugging in numbers. As you can see here, I have PV and then in parentheses 0.05, which is the interest, 25, which is the years, 0 for the payment, and 100,000 for the future value. It calculates out as a negative number. I would recommend any time that you are using a template or setting up the template that you actually use a cell identifier as B3, B4, B5, and B6 instead of actual numbers. In your homework, you'll find that it's not as simple as always figuring out the present value or the future value. There are times when another element is missing, and that's when it becomes useful to do the timeline and the list of elements that we talked about in step 1 and 2 before you solve. Once you identify the element that's missing, then you need to figure out how to calculate that element. Excel has a very nice feature that most of you will find already active in your Excel, and that is when you begin to type in the equation, it will finish that equation for you and let you know what elements need to be in that equation and in what order. So for example, if you're in your homework asked to identify the number of periods it will take to grow a certain amount to a certain amount at a certain interest, so you're calculating the number of periods, you can type into Excel equals NPER parentheses, and it will coach you to put in the rate first, and then the payment next, and then the present value, and then the future value. This also has a type, which you can just ignore for now, but we will deal with that in future classes. If you're asked to calculate the rate of interest, both of these calculations are rather difficult as math equations, and financial calculators and Excel just work much more consistently. So if you need to determine an interest rate, you can type in equals rate, R-A-T-E, and parentheses, and then it will coach you for the number of periods, the payment, the present value, and the future value. This can be very handy as all you have to really try to remember is the 4 equations are FV for future value, PV for present value, NPER for number of periods, and rate, R-A-T-E, for the interest rate.